Hello there reason people, PoohBear here and welcome to my channel. This is just a very quick update on my in-C project and where I am. I've actually hit on a few issues over the last couple of days. One, I actually had to go back to the dev to do with the dual CV source. The issue wasn't actually with the dual CV source itself, it was an issue really with the way Reason was utilizing the graphics. Basically, I essentially crashing Reason. It's quite a first for me on a released product. It turned out, as I say, it was a graphic issues on Windows itself. I believe the Mac's perfectly okay. I had to make a registry setting, and since I've made that setting, everything's working. So I couldn't have more than, I think it was something like 34 or 37 dual CV sources without getting Windows to do some funny things. It is quite a graphic intense little monitor, that dual CV source, because it's got two monitors on the front and it's got two monitors on the back. But as I say, that was a kind of Windows issue, Reason Windows issue. Change the registry, sort it out. I'll put in a link what registry setting I changed, just in case you might want to find out more information about that. So I've also hit on quite a stumbling block to do with my blocking. So just a reminder, what does blocking mean? Well, I could have an instrument here who's on phrase number 7, I could have one who's on 10, and basically, because 10 is obviously 3 phrases in front of 7, this one can't move on anymore, so I've got to block it and say, no, you can't go on to 11, you've got to wait until this instrument moves on to phrase 8, and then you can move on. Now, I had a prototype running, which was, well, obviously you could probably see that in my last project, but the issue with that prototype is when you start to scale up, say, across to 16 instruments, because that's what I'm hoping to do, you'll end up having to build a matrix which would be 16 by 16, which is 256. So it'd be 256 connections between all your machines. That way I'd have to have a minimum of 256 spiders, a minimum of 256 AB switches, a minimum of, I probably don't actually have to use the dual CV source to actually do the calculation on that particular part. But I'll have to use other devices to get my final calculation. So you can see that would have been such a resource intensive process. Yes, I could have wired it up, it wouldn't have taken as long as it sounds, because it would be probably a lot of copy and pasting, but yeah, it would have just been a resource killer. So I went back to one of my old ways I've done things in the past, is where you build yourself some multiplexers, demultiplexers, and you scan between them. So this is like obviously an 8 in going to 1 out, and then this is a 1 in to 8 outs. So you could sort of double this up, so you've got yourself 16 devices up there, and then this would be 16 down here. So you can actually then build yourself a matrix between them, because I can obviously activate port 1 here, port 1 there. Well, that would be the same machine, but obviously port 2 and that one, and this is how you can link them. And as you can see, I've got this LFO absolutely whizzing around. I was looking at this as a solution, but then I was starting to hit obviously on timing issues when I scale up, as well as other little funny issues with the CV select switch. The CV select switch, don't worry, I've used this for years. It's brilliant. The only thing which is not so nice about this, I say not so nice, is you can't turn it off. Whereas this 1 in to 8 out, I can kind of point this at something a port which doesn't exist. So it's effectively like turning this off. This is always live. A switch will always be active. There's no way of turning it off. A bit like patterns in sequences and a number of other ones. You can actually, in polystep, you can obviously, you can't on the front, but via CV or via your combinator, you can actually turn the patterns all the way off, or you can select 1 to 8 patterns. So that was a semi-problem with this, which isn't a real issue, because I could stretch my LFO to go into a minus figure, offset it so it's still finished at 1. So when I was in a minus figure, I could use an AB switch, which effectively would turn this off to allow me to do a little bit of calculation, because you have to discouple. And what I mean by that is, so this over here could be my machine. While I'm doing my calculations, I have to break it so this doesn't know what's happening over here, because it's not programming. I'm not saying, right, oh, I'm doing this, I'm going to call this subroutine or this function, which is going to do this. This is running and doing all its calculations totally independent from what that's up to. It doesn't have a clue what this is doing, this doesn't have a clue what that's doing over there. So you have to sort of break it, do it. Then that's the nice thing about this, because I say, so I can set this to a port which doesn't exist, and then I can open the port up, send the result through, do a calculation again. The problem is, and I'm sorry, this is a big waffle. The big problem is obviously I've got 16 switches, and I'll end up having 16 ports, which is again 16 by 16, which means I have to do this calculations at least 256 times. Really, it should be 240. Because you shouldn't have to do the calculation on yourself, but because we're using LFOs, I will do a calculation on myself, which isn't a problem because I know I'm never going to be ahead of myself as well as I'm never going to be behind myself. So checking yourself, it doesn't make no difference whatsoever. But I have to do the calculation 256 times, and this is when we start getting into technical issues and timing issues, and this isn't going to work. Why? Because most people will run their sample rate at 44.1, so that's 44,100 samples per second. If you've got a buffer size of 64, that would be your lowest, because that's what I run at when I'm running a lot of CV stuff. Then I need to obviously divide that 64 into my 44,100, which gets you around about 689 collection points per second. Because I've got to run it at least within a 1/8, because this is how often I'm checking. I've got to try and get all this collected and done within an eighth. So if I was running at 120 beats per minute, then I've got to divide that other figure by 4, which means I'm going to end up with a figure around about 172. So I've got 172 collection points, and I've got to do 256 pieces of work. It doesn't fit. It doesn't fit. What happens if I go over that collection point? Well, because it's to do with blocking, and because of this randomization and the way it's working, it wouldn't be the end of the world for this particular project. But it's not a fantastic solution. So I had to step away. And by the way, the big solution of having 256 wires, which I was talking about, by connecting every single device to every single device, that wouldn't have been affected by my block size, because it can all happen within one collection. A lot of it will all sort of be going on in one collection, so it wouldn't be an issue. However, it would be a massive resource issue on the DSP. What we're looking at here, this project actually, this is just a scrap workspace where I go off and I do all kinds of testing. So I had to rethink this, of how was I going to work this. And by the way, you've got these matrices already in Reason. These are an 8x8, so these give you a 64 sort of solution. So you can do 1-to-1, 1-to-many, many-to-many, and many-to-1. So you can sort of configure all sorts of things up. And I was looking at all kinds of solutions to try and work out how can I do this, which isn't going to be like a massive resource hit. So I went back to basics. So the basics is, how do I work out I'm so far behind or ahead of someone else? Well, the maths I do is a little bit backwards, and the reason I do what I refer to as backwards maths is because I'm looking at a 0 point. So if I'm going like this 0 point, anything below it is like good, anything above it, like 0 and above, is not good. You know, it means I'm ahead. So what I do, and the way I calculate things, is I need to find which instrument is on its lowest phrase to start with, and let's just say, for example, it happens to be 5, phrase 5. I then invert that, so that gives me -5. So I'm below this 0 line. I then add another -3 onto it to give me like -8. And the reason I add that other -3 on is because 3 phrases. So I'm taking it back 3. And then I can look at my current step and simply say, well, if I happen to be on, obviously, phrase 7, well, that takes me across my 0 line. Sorry, if I'm on phrase 7, it takes me up to -1. So I don't cross my 0 line, so that's good. Obviously, if I was on, this is on phrase 5, this is on phrase 8, then that takes me up to my 0 line, which means I've got to block myself. And the reason I'm interested in the 0 line, because theoretically, it didn't matter if I was on phrase 4B 962, and as soon as I cross the zero line, I don't care about where I'm landing over this side. I don't care. It's that zero line I'm interested in. So that's where my logic is working. Because obviously we're taking these figures and then turn them into basic binary kind of logic of is it on or off, is it true or is it false type thing. So that took me down a slightly different route, and it took me to this mod cell saw. A mod cell saw is a selector and a sensor built into one. The part we're interested in on this device is, and sorry, I'm looking down on the floor to try and find my foot switch, because I use a foot switch obviously to do tabs and things, is this bottom row. What this does is it'll take all your different inputs and it will return you your highest value, and it'll give you your highest value out. It'll also give you an index to say, oh, which port was it, if you're that interested. Now, if you had this one and this one on that exactly the same highest value, it returns the lowest one, if I remember rightly. But obviously the level of the actual value itself, the highest bit, is going to be the same because they're the same. So this returns you your highest level. Well, I'm interested in trying to find out my lowest level, which is then very straightforward. I take my levels, obviously to my 16 machines, and I invert them. So now they're minus, so I've inverted them so they're minus. So now what was the lowest level, when inverted and put into here, is now the highest level. So the highest level coming out here really is the lowest level of the phrase I'm on. And so I could obviously put all 16 into this, get myself an answer. So I now know what the lowest one is, and I can then just do some very simple maths and I can grab it out. So we can actually, and I've scaled this up and put this actually into a live project, which is over in here. And am I on the right machine? Let's click over here. So I've got this working live. I realise as I'm going along, and when I was actually even talking about this, yeah, we've got spaghetti junction. I can get rid of one of these bits, and when I come out of my level, that's when I should actually add my other minus number on. So I need to minus off the equivalent of -3, which because we're in this funny CV world, I'm working in 0.008, so it'll be a 0.024 I'll have to take away. Yeah, don't worry about that bit. And so this is what this bottom bit is, but really I could get rid of this bit here, take my level out, do my calculation, and then put it into the lowest bit. And then this has to go off to each machine. So, and then in each machine, it is just then a simple case of taking it in, taking my current value and adding it on, and then that works out if it's blocked or not. It's as simple as that. So rather than having 256 of everything, yes, I still need a splitter and I still need one AB switch over here, and I've got that logic working up, and it works. It's working really, really well. I've refined my each instrument down a little bit. So this one will be just one single instrument, and I think it's refined quite nicely down to what I've got working. And by the way, a simple, silly little tip: when I duplicate this, I don't actually do a copy and copy this around. I will save this as a patch, and then I load it as a new instrument. And by saving it and loading it, you don't mess up all your labels, because it's so annoying. Obviously, like with the sensor, you can see the word copy, copy, copy. Well, if I was to do a copy of the copy, it'll end up saying copy, copy, and you know, it's funny that then if you copy your copy, you get a copy, 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 don't you? And the labels go all over the place. So by saving it as a patch and loading it, all your labels stay really nice without having that word copy and everything else over them. So I can load up this combinator. I've got myself loads of comments everywhere. So every time I load in an instrument, I've got to make sure, you know, I got to add into a CV4 into this from my starts. When I start my main switch, everything starts to work. I then obviously have to get another signal to do with my length and my times, because I've now got this little simple calculation in here to say how many times am I meant to loop before I go into this randomization of am I moving forward or am I carrying on? And I've actually found some of Terry Riley's existing notes of how you should be playing in C, and I'm kicking myself now because he referred to it as you should be playing each phrase around about 45 seconds. He said a minimum of 45 seconds, actually, to be perfectly honest. I've done it on lengths, and he's working on seconds, and seconds would have been so much easier to have done because we could have had just a simple LFO counting around to say, yep, you've done your time. You can now go on and work out your randomization if you're going, and your blocker if you're going to move forward or not. So I'm probably going to end up doing some kind of amalgamation over here, which I can do independently now because I've got this here, globally, to probably look at some kind of timer and the lengths and do some kind of maths formula over there to pump into here to work out how many times I'm going to go round things. So it would mean shorter things, I'm going to loop a little bit more, but then I've got that big 35 phrases, which is 8 bars. I don't want to be looping that sort of 20 times, or maybe I do, but that's something I need to look into, and obviously with a bit of maths I can probably take that down, looping a lot less, and then the short bars I can loop more. I can do something. We'll have a look and see how it sounds. And so yeah, so I've got a main pulse, so that's a big difference now. So I had my pulse piano going before, which you know, but this pulse now is driving all the other instruments on their counters, so everything's working from one LFO for the timer side of things. I'm going to do a separate video on this LFO section because this LFO section is going to be a weighted, I've got a weighted randomization process, and I use weighted randomization a lot, especially in generative projects, and it's a subject on its own right, and it deserves its own video actually. But the main point is everything is quite compact, I think, and I know I'm hitting 2 DSP bars down here, but let's be perfectly honest, one of the main reasons I'm sort of hitting this 2 DSP bar is I'm also running another project, so I'm not just running this project, I'm running obviously where I do all my horrible work and lots of experiments separate from this project. So that's where we stand. I said I was going to try and keep it short. It probably still gone on quite long because that's the way I am. Very sorry for that. So all I'm going to do is I'm going to let this play out. I've still got to choose the right sounds, because the right sounds within C make a massive sort of difference. I've still got to sort out the LFO sort of timing, as I say, the weighted randomization process, because I am going to have it it's going to be like a shifting weighted randomization process. So depending on if I'm ahead or front, how much the randomization process is going to, the weights. I'm going to be swapping weights around, so say I'll do a video on that. Anyway, so let's play this. It's got quite a long intro on the piano. I could say I can sort out later, and I've got a few other bugs to sort. I've got a few other issues I'm still working on, but this is where we've got to so far. So I'm going to say thank you for watching, and I'll let this go.